Hello, everyone. I am glad to be able to present to all of you this study about the effects of dietary lysozyme supplementation and animal variability on growth performance, body composition, and nutrient balance of growing pigs. So, first, let's discuss quickly the initial spark for this study. What is the lysozyme? Lysozyme has anti-inflammatory, immunological, and antibacterial properties. This enzyme has been studied as a potential alternative to antibiotics for livestock animals in recent years, and the effectiveness of this enzyme from different research has also been evaluated in swine production. Still, little is known about fungal lysozyme, which could be an economically viable search of this enzyme for non-ruminants. However, studying feed additive supplementation can be limited by individual animal variation. This variability results from differences among animals regarding intrinsic, for example, genetic, and extrinsic, for example, environment factors. Each animal responds uniquely to these factors, resulting in increased variability between animals, meaning that some pigs, for example, low responders in terms of protein deposition, might have a different response to enzyme supplementation than others. Therefore, the objectives of this study were to evaluate the effect of lysozyme supplementation on pigs' growth performance, and then to study if pigs with low or high protein deposition would respond similarly to dietary treatment. 72 barrels of the same high performance genotype were used for this experiment. The animals were all in good health when they were shipped as a single batch to the Agriculture and Agri-Food Canada Research Center in Sherbrooke. The pigs each had a low radio frequency transponder placed in their ear, so allowing access to automatic feeding stations and individualized feeding. Between their arrival and the start of the trial, the pigs were fed a commercial growing diet, and water was provided through low pressure nipple drinkers, and feed was provided ad libitum throughout both the adaptation 14 days and experimental periods 21 days with 5 feeding stations. And the pigs' health status was checked daily. The pigs were distributed in a complete randomized design with 6 treatments, 0, 16, 32, 48, 64, and 80 milligrams of lysozyme per kilo of diet, and 12 replicates per treatment. Pigs were group housed in the same pen, and individual transponder codes allowed feeders to identify individual pigs, record feed intake data, and feed to be provided according to individual pigs assigned treatment. All diet was free of antibiotics or pharmacological levels of zinc and copper. So the basal feed was divided into feed A, control, and B, lysozyme concentrate. Feed B consisted of the control feed coated with 300 milligrams per kilo of lysozyme. And then the treatments were created by dilution, where automatic feeders mixed the right proportion of feed A and B for each treatment. The pigs were weighed on arrival once during the pre-experimental phase for animal selection on days 0, 14, and 21 of the experiment. Animal growth performance was evaluated through average daily feed intake, average daily gain to feed ratio, and the lysine and threonine intake, and their efficiency of utilization for protein deposition, and protein deposition and lipid deposition. Total body fat, lean and bone mineral content and bone mineral density were measured by dual X-ray on the day 1 and 21 using the scintigraphy device. And then the pigs were scanned in a prone position using the total body scanning mode. So in relation, the statistical analysis, the growth performance analysis were performed using the R package software. So the growth performance data were analyzed as a completely randomized design using the specific package in the R, considering the individual pig as the experimental unit. So the main fixed effect was lysozyme dose, and the scanning day was considered as a random effect. The assumption of normal distribution of the error was checked graphically. The p-value less 0.05 was considering as a significant difference, whereas the p-value less 0.1 was considered as a statistical trend. Differences among treatment were analyzed using polynomial contrast from our basic package, and adjusted means were obtained with the means package of R. Animals with low, medium, and high protein deposition were clustered using the k-means techniques to study the response to lysozyme supplementation within each protein deposition group. And then the effect of the treatment, protein deposition cluster, and their interaction were using mixed model in our package. The result of this study in relation to growth performance, body composition, and nutrient balance were evaluated over 21 days. For this first table about the body composition of growing barrels fed different inclusion levels of lysozyme enzyme over 21 days, we can observe here that there was no effect on the animal's final body composition, for example, for protein deposition, lipid deposition, and protein deposition and weight gain among treatments. So to our knowledge, no previous study has tested this enzyme in the body composition of the animals for growing pigs. It's expected that there would be no effect on the body composition of animals due to the functions and actions of this enzyme, for example. It's an enzyme whose main functions are its anti-inflammatory, immunological, and antibacterial action, which suggest a more targeted effect to protect the host against infection disease. In addition, the animals were housed in an environment with optimal experimental conditions, allowing them to express their maximal potential or maximum genetic potential, and therefore keeping their body composition constant throughout the experimental period. However, growth performance was affected by dietary lysozyme supplementation. So here, during the 21 days trial period, average daily feed intake decreased linearly as the level of lysozyme in diet increased, while the body weight, average daily gain, and feed efficiency increased linearly as the level of lysozyme in diet increased. So here, the improvement in this feed efficiency is due to the linear increase in average daily gain and linear decrease in average daily feed intake. So other hypotheses may help to explain the better feed efficiency and performance response in these animals could be related to the main functions of this enzyme, such as some regulatory effect on the intestinal microbiota, for example, or protection of the intestinal barrier and attenuation of the immune response. So what can be confirmed by microbiome analysis in the future for this project. So nutrient balance was affected by lysozyme inclusion in the diet, so resulting in a linear decrease in the consumption of lysine, threonine, and crude protein intake as dietary lysozyme increased, while the efficiency of lysine and threonine utilization increased linearly as dietary lysozyme levels increased. However, given the improvements in the feed intake of the animals that received the highest lysozyme supplementation, it's reasonable to expect that there would be an improvement in the efficiency of these amino acids due to the lower feed intake observed over the 21-day period. For the nitrogen and phosphorus balance, the decrease in nitrogen and phosphorus excretion resulted in a linear increase in nitrogen and phosphorus efficiency as the level of lysozyme in diet increased. How much nitrogen or phosphorus is excreted depends mainly how much nitrogen or phosphorus is ingested. And in this current study, a reduction in nitrogen and phosphorus intake can be seen with increasing levels of lysozyme supplementation as a result of the lower feed consumption during the experimental period. When studying the growth response of low, medium, and high protein deposition pigs, a trend interaction between treatment and protein deposition clusters in body weight and average daily gain were found. So this trend showed that the treatments have a different effect for each protein deposition group. For example, low and medium protein deposition pigs presented a linear body weight increase as the level dose increased. Areas the treatment had no effect on the body high protein deposition clusters. Moreover, as you can see here from this graphic for average daily gain, low protein deposition pigs presented a linear average daily gain increase as the lysozyme dose increased. Areas the treatment had no effect on the average daily gain of medium and high protein deposition clusters pig. This difference for average daily gain and body weight on the lysozyme supplementation effect on different protein deposition clusters may be related to animal intrinsic variability both among and within treatments. Other point is we can also observe that there is a variability between these groups in the same treatment, and that when considering this variability, lysozyme supplementation may have a greater effect on the low protein deposition group. That is, this enzyme could be more effective for example, for animals with low protein deposition than medium or high protein deposition. So about the conclusions of this project, the growth, performance, and nutrient balance in this trial were affected by the inclusion of lysozyme in diet. So growing pigs decreased feed intake while improving average daily gain and feed efficiency as the level of lysozyme in diet increased. Lysozyme supplementation improved the efficiency of lysine and threonine utilization, as well as increased nitrogen and phosphorus utilization. Furthermore, the results of this trial indicate that the effect of lysozyme supplementation on body weight and average daily gain has a differential effect based on intrinsic variation in protein deposition, for example, low, medium, and high protein deposition. And lysozyme was shown to be more effective for animals with low and medium protein deposition than animals with high protein deposition. So based on these results, supplementation of lysozyme has great potential for precision nutrition and targeted health applications. So I would like to thank the employees of the Agriculture and Agri-Food Canada Swine Complex, and my advisors, Cândido Comar and Aline Remus. In addition, I would like to thank Concordia University for their support, and to Elanco Animal Health for support and financing of the project. And thank you for listening.